Today we're going to talk about relativity in motion. First question for you, what is my present speed right now where I stand? Go ahead and think about that one. I'll give you some choices. Is it 0 meters per second? Is it 30,000 meters per second? Or is it over 50,000 meters per second? Well, if you said 0 meters per second, you're correct. That is my present speed given the relativity to the floor. Where I stand relative to the floor, I'm moving at 0 meters per second. If you said 30,000 meters per second, that is also correct. That is my speed relative to the sun. As we stand on Earth, we are moving at 30,000 meters per second around the sun. If you said over 50,000 meters per second, that is also correct. That is our estimated speed, and people don't even really know the actual value, but that is the distance that we are moving away from the center of the universe. So my speed is relative. I could, depending on what we're talking about and what we're relative to. Okay, well, let's look at some examples. I've got a race car. That race car is traveling at 300 kilometers per hour. Okay, that speed is relative to the track. If that race car is passing another race car that's going 295 kilometers per hour, the speed relative to the slower race car is 5 kilometers per hour. So again, relativity. Let's look at another example. Let's say I'm on a train and that train is traveling at 10 meters per second. I am on top of that train doing a very unsafe thing. I'm throwing a football in the direction that the train is moving. Don't try this at home, okay? I'm throwing that at 8 meters per second, okay? Well, the ball relative to the train is moving at 8 meters per second, but the ball relative to the ground, or people standing on the ground watching, is 10 plus 8, 18 meters per second. Okay, so that makes sense. And this works really well at relatively low speeds. And trains and cars and me, we're all relatively slow, okay? It doesn't work so well at really, really high speeds. So now let's look at another example. I've got a train moving at 10 meters per second, and I have a headlight on that train. And that headlight is traveling at the speed of light. Okay, the speed of light is 300 million meters per second. Okay, so I say, well, that's easy. I've got 10 meters per second plus 300 million meters per second, which is going to be 300 million and 10 meters per second. Okay, unfortunately, it doesn't work that way. Einstein discovered, in what we call Einstein's special relativity in motion, that nothing can go faster than the speed of light. So that light coming out of the front of the train, no matter how fast that train is going, if it's going half the speed of light or if it's going 200 kilometers an hour, that light is traveling at the same speed. So these are the ways we work with relativity in motion.